Alright guys, in this video I'm going to explore various factoring methods for trinomials, show you how to do various methods, show you why they work, and then I'd like to conclude with my own thoughts as to why I'm not a very big fan of most of these new methods of factoring. Okay, so let's start with a problem. Let's say I give you 12x squared minus 5x minus 2. And I ask you to factor. Now, if you've been watching these videos that I've been posting about factoring methods and how to factor, what you would see in my videos is that I would be breaking these down into a sort of guess and check method. So what I would do is I would break them into two quantities, and I would ask myself, what times what is 12? Let's say I'm going to say 4x and 3x. Okay. Then I would go back to 2, and I would say what times what is 2? And that would be 1 and 2. Okay. From here, I would see that 4 times 2 is 8, or 8x, and 1 times 3 is 3, or 3x. And because negative 8 plus 3 gives me negative 5x, which is, this negative 5x is the same thing as what the middle term is, that's what I'm striving for, I know I've picked the correct combination, so I would make this value negative and this value positive. Now, why is this true? Well, you can see that it's true because if I FOILed this out, if I did 4x plus 3x, I would get 12x squared. If I did so I'm doing 4x and 3x, that would give me 12x squared. Then 4x times 2, that would give me negative 8x. 1 times 3 is 3x. 1 times negative 2 is negative 2. And because these are like terms, we can put them together and get negative 5x minus 2, which is the original value. Now, I like this method. I'm a big proponent of this one because it's intuitive. It makes sense. We're just basically we're just reverse foiling. Now, there are other methods that have been developed in terms of how to solve this. And one of those methods is called the AC method. And the AC method works like this. So we're given 12x squared minus 5x minus 2. And what the AC method says is that you multiply these two together, and this gives you 24. Now, what you want is to find the factors of 24 that add or subtract to 5. This would be 8 and 3, right? 8 times 3 is 24, and negative 8 plus 3 is negative 5. So then I go back here, and I rewrite negative 5x, so note I'm writing this whole negative 5x as negative 8x plus 3x minus 2. So essentially, this is what I'm doing here. Right? I'm writing it in such a way, this middle portion, I'm rewriting negative 5x as negative 8x plus 3x. From here, what we do is we take these, we take these four terms and we siphon them off into two binomials. And now we apply what's called factor by grouping. So I ask myself, what does 12x squared and 8x have in common? And we can see that they're both divisible by not only 4 but x. So we can factor 4x out. And that would leave me with 3x minus 2. And 3x minus 2 has technically a 1 in front, so I can write it as plus 3x minus 2. Now, what happens here is because both of these have 3x minus 2 in common, I can factor a 3x minus 2 out, and I'll have 4x plus 1 in the back. And what you'll notice is that this method and my original method of factoring produce the same result, albeit the order is switched. Okay. Now there's another method called the slip and slide. And some of these have multiple names. So you may know these methods by a different name. The slip and slide method is a variation of the AC method. So again, we start the same problem off with 12x squared minus 5x minus 2. And we do the same thing as with the AC method. We say 12 times 2 is 24. Now, though, we rewrite it as x squared minus 5x minus 24. By the way, when I say 24, I mean negative 24. And now we just simply factor this out. And this is easier because the leading coefficient is 1. So this is simply, we say what times what is 24, and adds or subtracts to 5. So 8 and 3, we know this because we've worked this problem out many times. So we go 8 and 3, and we put a negative and a positive so that we get negative 5. Now the move here is, what we really have here now is that we have to take this number in front and we divide them, the back number, by both. Then we reduce. So 8 and 12 are both divisible by 4. This would leave me with 2 over 3. 3 and 12 are both divisible by 4. This leaves me with 1/4. Now, this is a viable solution, but the way the method typically tells you to do is take, if it doesn't go in evenly, and even it actually does, you take the denominator and you just slot it in to the front. And this produces the same result. Okay? So, the slip and slide method is actually a variation of the AC method. But a question should be emerging in your mind right now. And the question that should be emerging is, why do each of these methods work? Well, the first method, it's intuitive why it works, right? We're basically doing foiling in reverse. And this is why I like it. It's straightforward, it's intuitive, it makes sense, and it jumps you straight to the answer. But why does the AC method work? So this next part is where I get past the sort of functionality of how to do the procedure, which is what you would be tested on in most classes. I'm going to explore a harder question, which is the origins of why these methods work. So let's start with the AC method. Why does the AC method work? Well, let's say this. Let's argue that ax squared plus bx plus c factors out to dx plus e times fx plus g. Okay? And all I'm doing is I put letters in place instead of numbers. And this is how we have to go about doing a proof, because we have to show it's not true just for one case, but for all cases. So the letters represent any sort of scenario. Okay? So we're going to FOIL the back part out. And this is going to give me dfx squared plus dgx plus efx plus eg. So all I'm doing here is dx times fx is dfx squared, dx times g is dgx, e times fx is efx, and e times g is eg. Okay? So let me erase this so the underlining doesn't confuse. Okay. So we're here. Now, we can do this sort of grouping effect with here, because since they both have x, we can rewrite this as dfx squared plus dg plus ef times x plus eg. And if you're not seeing it, what I did here is I essentially factored out an x, and I put it in the back side instead of the front side. Okay. Now, what this tells me is if the right-hand side, remember, is the same thing as the left-hand side. Okay? And what this is telling me is that A matches up with DF. So A equals DF. Okay? We also know that DG plus EF is B. Is B. And then the back side, let's go with yellow. Actually, let's go with purple. I think purple sticks out more. This is EG, right? EG matches up with C. Okay? So, what you need to realize is that when we call it the AC method, right, when we go back to here, remember we said we multiply 12 by 2. Now this is technically ax squared plus bx plus c. So when we multiply, we're multiplying by AC. So 24 is going to be AC. Right? So notice that AC here is DFEG, and B is still DG plus EF. Okay? Why is this? This is essentially the proof. This shows us why. And let's see why that's the case. So if we look back here, we don't really need this X here. Let me take them out. What did we do? We said 24 factors into 8 times 3, and 8 times 3 represents the middle portion. So what I'm saying over here is that because I can rewrite this product as the sum of the two parts of it, it will always break up into a way so that I can always do factor by grouping. This piece right here will always, in particular, let me back it up to here, this part here will always break up in such a way that I can pair these two together, right? And we can see we will have common terms. And the back part together, and we'll have some common terms. And it'll factor out such that we can do factor by grouping. And that's a little complicated to see, but if you think about it, it makes sense. I'm going to return back to this a little later too, and show maybe a different way of showing how this works out. Okay, so there's the AC method. Now, there's another that we have the slip and slide. Why is the slip and slide true? Well, to show this, the first thing I want to do with the slip and slide is show you why the slip and slide works with our example. The slip and slide method is not as intuitive as the AC method. So what we're really doing initially in the slip and slide is we're multiplying by 1, but we're writing it as 12 over 12. And what we do is the denominator and the numerator of 12 over 12 get separated. So I have 1/12 times 12, parentheses, 12x squared minus 5x minus 2. Now I separate it like this because now I'm going to take this 12, and notice that this is totally legit because this is still giving me 12 times 1/12 is still 1, right? I'm going to distribute this 12 into everything, and I'm going to rewrite this as 1 over 12, parentheses, 12 times 12x squared minus 12 times 5x minus 12 times 2. Now, here comes the genius move. We're going to take this, and I'm going to rewrite this part here as quantity 12x squared. I'm going to take the 12 and the x, and I'm going to pair them together. I'm going to rewrite this as 12 times x in parentheses, and put the 5 in the back. Actually, you know what? Let me flip it. Let me put the 5 in the front. Let me put the 12x in the back. In the back part, I'm just going to leave it as 12 times 2. Okay, and keep in mind that we do still have the 1/12 in front. Now, why is this the genius move? Because we're going to pick a letter. I'm going to just use Q. I'm going to say Q is equal to 12x. And what we're doing now is I can rewrite, if this is 12x and this is 12x, I can rewrite it as Q squared minus 5Q, and now I'm going to write it as 24. Aha! So what did I do? I created a trinomial that has a leading coefficient of 1, which is very easy to factor. I just look at 24 and I say what times what is 24, and adds or subtracts to 5. That is 8 and 3. Now I made a silly mistake here because this is negative and this is positive. Now keep in mind that we are not solving though for Q, we're solving for x. So we can rewrite this now as 1 over 12 times 12x minus 8 times 12x plus 3. And what we can see here is that we can take what these have in common, which is a 4. We can factor that out, and that'll leave me with 3x. I said 4 minus 2. And over here we can factor out a 3, and this will leave me with 3 times 4x plus 1. And now we can rewrite, since 4 times 3 is 12, and we have the 1/12 on the side here, to finish it off, these will divide out, and I'll be left with my answer. So that's actually what's occurring with the slip and slide method, right? I'm using an example here to illustrate it. But what I want you to see here, and let me go in a little bit more depth here. So what I'm saying here is that what we're really doing in this part right here is this part right here where we've rewritten it as in terms of Q. It's a slick way of representing it. And that's why we have this divided by 12 business here. And that is getting eliminated in this part right here. Okay. Now, I'm not going to do in this video. I will in another video show you in terms of, this isn't actually a definitive proof. This is just a sort of an explanation using an example of why it's true. I'll make a subsequent video on slip and slide to show you why slip and slide is actually true. But what I want to stress here, and sort of my apprehension and my disdain and my dislike of these other methods, is that I think in a certain sense it runs counter to what we're doing with math. So here's a little commentary by me. I just feel though that this is an important idea to discuss, so I'm going to present it, and hopefully there can be somewhat of a conversation about this. But the initial method to me, this right here, of guessing and checking, it makes complete intuitive sense. There is very little thought as to why it's true, right? It flows. It's very, very direct. These other methods have been sort of developed and are being used more and more because it allows you to take a shortcut in thinking, right, with this 24 in terms of figuring out what works. The cost in doing this initial method is that I have to guess and check. Now, I wrote out the answer fairly quickly. I got lucky on my first try and I got it right. And so I didn't have to spend that much time working through. But it could potentially, with 12 and 2, it could take me some time to figure out which value works. But you can just grind away at it. Whereas with this, it seems to almost more directly get you to what works, right? 12 times 2 is 24. What multiplies through to get me 5? So there can be, in a certain argument, a lot less work that you have to do. The same thing's true with the slip and slide. All right, slip and slide, you can see, is almost just a variation of the AC method. And there doesn't seem to be much thought entailed in it. My apprehension and my sort of like dislike of this method, though, is that to prove why it's true, to see the actual reason why this is true, actually takes a tremendous amount of effort and insight. And let's be honest, most people, when exposed to this, do not see why in any sense. Even here, I'm not actually proving why it's true. I'm just showing you an example that shows it to be true, right? It takes quite a bit of effort to show that it's true. So in a certain sense, when this method, the AC method or the slip and slide method, is being taught to you, you are just taking it on, I can't think of a better word to say, than in faith that it's true. It's true because your teacher said it's true. It's true because the book says it's true. It's true because figures that seem to know what they're doing are telling you it's true. And that's where I have a problem with this. My appeal, the appeal math has always had to me, is that it's not true because I say it's true. It's true because of a logical process that shows it to be true. And when we teach these sort of, I'm using this in air quotes, shortcut methods, I feel that we're stripping students and ourselves oftentimes with why this is true. And remember, we're all students and we're all teachers at different points of, whether it be in life or even in a classroom, right? When I teach a class, sometimes I'm learning from the students. And then hopefully the students are learning from me. So we all switch these roles. We all change the hats that we wear. But I think that we're doing a disservice when we don't explain why things are true, when we don't try to look at why it's true. And the true notion of why I think we do math, one of the biggest reasons why we do math, and a lot of times students say, well, hey, I'm never going to really use this, right? Number one, that's not true. You'd be amazed as you progress through school how much math is entailed in subjects you'd think you have very little math to be entailed in. But second of all, math is teaching you how to think. And one of the biggest aspects of thinking is connecting the dots as to why things work. Why does it have to be the case that this always works? And we're not and we tend, when we show this, we show mechanically why it's true, that it works, but we don't actually explain why it's true. And in doing that, we're stripping ourselves of understanding something so much deeper and something more. And trading that in for saying, because the person says it's true, I accept it as true. So, I know I'm going on a bit of a ramble here, but I really do think that if we're going to show methods like the slip and slide and the AC method, then we need to show, even if it's difficult to see that it's true, we need to try to show that it's true. Because if we don't, then we're in effect making an ad hominem argument almost. We're saying it's true because some figure of authority said it's true. And that is to take away one of the most beautiful things that math can teach us. Truth, because it has to be true. You have to accept it because it just is. So, if you made it this far and you heard me ramble on about this and you found insight into it, I'd love to hear your comments. Feel free to give me some comments. Am I right? Am I wrong? Is there more to look at this than what I'm seeing? So please post some comments. Love to hear your thoughts. And I will see you in the next video.